Okay, I think we're all set. So let's start. Okay, for everyone that doesn't know us yet, my name is Clement Logar. I'm head of sales at Insight. And today we're going to focus on how to migrate from IBM Netezza to Snowflake data clouds. Since our presentation is going to be quite technical, I would like to introduce my colleagues, both Netezza experts that are going to help me with some juicy details and hands-on information. So before further ado, introducing Jako Kaučić, senior consultant at Insight, and Grega Jarkic, CEO, senior consultant, and solution architect at Insight. As you may already noticed from our previous webinars, we are going to talk about migration to the cloud. All the webinars are intended for companies that already decided for cloud, but don't really know or still struggling to find the best approach, the best solution, and best practices. So if you're among those companies, you're definitely at the right place. We had our first webinar a few weeks ago where we were discussing how to successfully prepare and execute the migration process. And you can find that webinar recording on our webpage. You will, of course, also receive a follow-up email with all the recordings from our marketing team as well. So before we start with the presentation, just a few words about Insight. Insight company has been established 11 years ago. We had 11th anniversary this year with almost 60 employees already, of which 43 consultants, architects and developers, and 23 employees with more than 10 years of experiences on data warehouse modernization, greenfield projects, focusing exclusively on business analytics. Altogether, we have 150 plus successfully finished projects. Now, for the successful partnership, we consider that it's crucial to understand customer business and provide the highest quality of service, and of course, among that, have the technical expertise. That's why on every project, we invest heavily in knowing our customers' business processes and, of course, to pick up the best possible technology. We're focusing on these 5 industries with our core focus on banking and insurance, because this is where we have most of the business and technical expertise. We have done migrations from traditional on-premises databases or platforms such as IBM, Oracle, Microsoft, Informatica, and SAP, and of course, not only to Snowflake, but also other modern platforms running on different public cloud providers from Azure to AWS. Our work focuses on consulting. So basically, we are technology biased and we are the customer advocates, because we believe that we have to choose the best technology that actually fits the customer needs. So the architecture, the implementation, education, advanced analytics solution, this is basically our focus. Everything from data warehousing, modernization, data integration, master data management, and of course, different business intelligence and planning solutions, all the way to advanced analytics, AI, and machine learning. Very important, and what I would like to point out, that since 2016, we have been focusing on cloud-first strategy. So we've done more than 10 modernization or migrations to the cloud, and we would like to share our vast experiences we gain throughout the project. So everything we learned from the mistakes to the best practices. So we have basically the consulting approach, and we try to move as much knowledge we have to the customer team. Our idea is not really to lock in the customer to a certain technology or to us as a vendor. it's important to put the customer first, deliver the services and the technology that really fits best to their data landscape and their business needs, and of course always put the customer first. And you will actually hear that we are focusing and pointing this out because we believe that this actually makes us different from other vendors. So not really being advocates of a certain technology, but basically finding the best fit for the customer. Of course, we launched the webinar series, and as mentioned a few weeks ago, we started off with how to start the migration. Now we're going to focus on Netezza, and coming up, Microsoft SQL Server on-prem to Snowflake migration, Oracle Exadata to Snowflake, and then we're going to continue with our internal assets that we developed to basically speed up the migration projects. Now, I would like to pass the microphone and screen to Grega, who will continue with hands-on presentation.
Okay, sorry guys. Welcome everyone. As Clement said, my name is Grega, and for all those that joined the webinar 2 weeks ago, so with Luca and Katya, we explained how we usually start the projects. So now we will focus on technical details when it comes to Netezza, so that for all of those that are looking more at a project-based approach, what to watch out, please watch our previous webinar. And as this one will be really focused on technical parts, what you have to watch out and what we have learned migrating from IBM Netezza. Okay, so regarding the Netezza, just to tell you a little bit about our story. So we've been working with Netezza since 2005. I believe we had one of the first of the 10 implementations in Europe. It was in our national telco operator. A lot of the people that work on that project are in our company now. And through all these years, when IBM acquired Netezza, we became IBM premium partner, had a lot of different implementations of Netezza, either as a standalone or as a DB2 accelerator for all of those that are using it as a mainframe accelerator. So I must say we are still in love with it. So I think it's the best, it's of course very subjective and personal opinion. It's the best on-premise appliance. So I love the simplicity. So no indexes, no partitioning, just run and it runs fast. And I think it's a very, very good piece of technology. Of course, it has its own problems or issues that were never, let's say, really solved. One is certainly concurrency. So all of you are running Netezza, you know what I mean. When you run a big, heavy query, it can take all the resources. So it's very fast on one query, but when you have hundreds or even 10 let's say, huge queries running, it can start becoming very problematic. So what also happened is, you know, IBM focused to remove Netezza. So the idea was to focus on the new appliance and the new solutions that are coming with the cloud. But let's say last year in summer, if you remember, there was like a new marketing announcement that Netezza is coming back. It's called now MPS, and Netezza Performance Server. So it's the same logic, better new hardware, and also there are now some cloud possibilities. Of course, these cloud capabilities are currently very limited because it's quite a new entrance to this market, and it's more of a standard approach moving to cloud. So it's not cloud native, and there will be still some needs in the future to address this by IBM. Just a second. Okay, so regarding client's experience, what we noticed using all these years. So the biggest differentiator compared to some other on-premise solutions was like, you don't need a DBA almost anymore. So there is no partitioning, no indexes, simplicity, which is very important. And what was also important that you could really write almost any kind of SQL. So even if you didn't follow all the best practices, the Netezza power of the, let's say, logic that it pushes down the processing where the data is could handle a lot of complex queries, even if they were not optimally written. What also happened is that a lot of companies switched their data integration logic. So something that is now coming with the cloud, that you don't want to have a middle tier strong, so that you will have an ETL platform like DataStage, Informatica or something, where you would process the data and then just write the results to the data warehouse. So this logic died a little bit with Netezza, because Netezza was so high performant that the idea was extract the data as fast as possible to Netezza and then do all the transformations inside the Netezza, because you could get a magnitude of benefits and faster processing compared to do some things, let's say, on the middle tier of some ETL platform. And then at the end, of course, all these ETL platforms all these clients were used as a, let's say, a scheduler or orchestrator of everything. So a lot was pushed down to the database. And this is, let's say, something similar that is also now best practice when it comes to the cloud databases. Today we will look at some migration specifics. So we will look at some of these standard topics, like how you set up, how you load the data, how do you extract the data, which is important because you have to do some initial load. We will look at the code conversion, what are some specifics, and of course optimization, because you will see that also on Snowflake, if you optimize some parts, even though it's, let's say, marketed as you don't need to, but it's good to maybe optimize some parts. And then also this comparison, so that we don't look always at the demo databases or some TPC benchmarks. So we will put some graphs from our own experience when moving some very large clients. And then at the end, a little bit about the maintenance, what changes, what doesn't change, and etc. What is also important is that today we will focus on two approaches, so lift and shift and small adjust. So we will not talk about modernization, because modernization means building everything from ground up. So we are targeting now at these two areas and to get you, let's say, more information in this setup. So I will now leave to Jaco to go over a little bit about some of these topics that I narrowed down.
Yes, thanks, Grega. I'll be talking, sharing our experience with the first two steps of an immigration process, so environment setup and then the initial load of the data. So let's start with the environmental setup. First of all, we had, well, I was in a project where we had some issues with networking. So it's very important to have a conversation about how will the on-premise environment connect to the Snowflake instance. So if there's a private link, direct connect, or whatever service in between, that should be considered, and all the on-premise environments should be adjusted or set up so the communication works at the beginning. For then the next step is getting the Snowflake account. Once the account is available to the customer, or the customer has all the credentials to log in and start using the warehouse, I would strongly suggest that a longer conversation is had about how the data will be stored within the warehouse itself, which schemas, which databases, and so on will be created. Also, the naming conventions are important, as we all know. Then based on that, you can also have a conversation about security. How will the roles be created? Which roles need to be created right out of the gate? Which can be created later? And so on. One of my mistakes was getting this pure Snowflake account instance. And I just started using it right away without creating a new role. I started using the sysadmin or security admin roles, which is not recommended. It's a bad practice. And finally, we were able to reconcile that mistake we made. So security conversation is very important at the beginning. It will lead to a better architecture down the line. Then additional layers, services can be connected to the Snowflake instance, for example, S3 buckets, blob storage containers, and so on. So if you have any data in the cloud already and want to use it in Snowflake, you can connect your cloud storage to Snowflake, and it will be available to you. Snowflake already comes with an internal stage, so some cloud storage, which can be used for migration purposes. So this step can be postponed to a later date. Once the cloud environment is set up, so the first 2 points, we can start talking about the on-premise environment. First thing that will be needed is an on-premise server, which will receive the CSV files or the data from Netezza. There it can be staged, gzipped, and later pushed to cloud storage. It's very important to decide or to approximate how much storage will be needed, how much memory, how much CPU, and so on, because this can become a bottleneck within the migration itself. So this will tell you how big your a single load can be, and so on. Another thing that can limit a migration is the migration project is the available bandwidth. Since all the data has to be transferred from on-premise to cloud, this can have a considerable impact on the production environment, and a conversation has to be had about time slots. When can data be pushed to cloud? How much data can be pushed? How many parallel put commands can be performed, and so on. So Grega, if I can have the next slide. Thanks. Okay. So once the on-premise environment is set up, you have to start preparing the CSV files. This will be the source of the data for the new data warehouse. So for extracting data from Netezza, we suggest you use create external table as select statement. With this statement, you can create a CSV file that can be later pushed to cloud. This approach also allows you to create multiple partitions of larger tables. In our previous migrations, we targeted a 1 GB size of a CSV file. Too big of a CSV file can bog down the transfer, can lead to some errors, and so on. So it's best to partition it in the beginning and not worry about the possible errors. Finally, well, in the statement itself, you can also adjust the export. So you can specify what kind, how will the timestamps be stored, how the null fields will be represented in the CSV file, and so on. You can also specify the encoding and everything else. This has to be connected with the file format that will be created in Snowflake. So here we are writing the data. The reading process has to be synchronized with the export. This will streamline the whole migration and is almost a necessary action. Finally, I would like to just mention an encoding issue we faced when exporting data and ingesting it into Snowflake. In certain cases, car fields were encoded differently than the rest of the fields. So we ended up in a situation where we had a single CSV containing 2 different encodings. Most of it was encoded with UTF-8, but certain fields were encoded with Latin 9 encoding. We haven't found this root cause for this issue, but we found a solution. If all the car fields or var car fields are converted to uncar or Anbarkar, Anbarkar, the issue is resolved. So you should experiment with your tables containing card fields and see if the same issue will present in your project. As alongside this issue, there are certain standard migration issues that any migration will face. So when to export, how to retain the data warehouse integrity, relational integrity, and so on. So certain time slots have to be designated a certain time, so that the data that's exported still has relational integrity and can be used later in migration without without issues. That's of course simply a simple issue to foresee. Next, something that helped us to decide what kind of load we will perform in a day. So we split our migration, our load into multiple days, and each day we found a set of tables that wouldn't be too big, wouldn't cause too much stress on the on-premise environment, and so on. So we found that 3.5 to 4 is the best approximation of a compression factor from Netezza to CSV. So in Netezza, you can find the compressed size of each table, and from that you can calculate the approximate CSV size. Next, based on your available network or the time window, you have to decide how many parallel processes can run. So parallel put commands will put stress on the on-premise system, on the network, and the on-premise server as well. So this should be decided. You can experiment with it and find the optimal setting for you. Finally, we have to mention the AWS Snowball and Azure Databox services. In case you have an immense amount of data and don't have the network needed to transfer all of it to the cloud, you can use one of those services and try to find a different solution to the migration. Can I get the next slide? Thanks. Finally, I will just mention some of our results. So this is the high level. Basically, you can use this as an approximation of what to strive for, what kind of performance you can expect. So in this situation, we had an environment with 1 gigabit per second network. That's the network outside of the private network going out. We found a set of 147 tables, or 97 gigabytes uncompressed, and we transferred that to Snowflake. We had 10 parallel put commands and 4 parallel copy commands. We found the best results with those settings. Because the put command, the Snowflake put command, which I strongly recommend, has the ability to compress files before sending them to the cloud storage, we were able to have a smaller impact on the production environment. So instead of sending 100 gigabytes over the network, we sent only 7.7 gigabytes, which is gzipped data. And also the traffic impact was about 100 megabit per second. So it wasn't, it was less than, it was 10% of the whole bandwidth available. Here on the right side, the most interesting results is, for example, we needed around 16 minutes to transfer the whole 100 gigabytes. From the table, it would seem that the load was faster on an M warehouse instead of an L. This is misleading. Most of the time, most of the 16 minutes was spent gzipping the files, putting them to cloud storage, and only a small percentage was spent copying or ingesting the data into Snowflake. So Snowflake didn't have that much of an influence over the whole duration. I went back and checked what was the reason for for the difference, for the faster load on M, it ended up being, we had more traffic, more unrelated traffic on the network for the second attempt, whereas the first one had more network available. So yeah, we found these results to be very impressive and more than satisfactory for our needs. This is all from my side. Thanks for, yeah.
Thank you, Jakob. Yeah, this is, let's say, a very important part that Jakob showed. So always checking your data bandwidth. So we have these questions a lot when people are moving to the cloud. What kind of bandwidth do I need? Can I really do this? Can I move such amount of data? And also what Jakob explained, so when you move something to Snowflake, let's say that it took 13 minutes or 12 minutes to move the data, so you don't pay when the put command is running. So you pay only for the copy command. So that's also important. So just to understand some of the optimization techniques when you're moving, let's say, more data. But let's say with some clients, we have a daily delta of, let's say, 0.5 terabyte. And then, of course, you have to adjust this and see what is best. But you can still see that you can get really good performance. And there are mostly the question is about the initial load. Okay, let's move on. Code conversion. Okay, so Netezza is based on PostgreSQL, as you know. It means the dialect is very similar to Snowflake, very, very similar. There are some small changes. So when you will compare the DDL statements, data types, so what can happen, maybe interval type is not supported in Snowflake, but we usually don't encounter this on Netezza that someone will be using interval type, but just to know if you are using it. In terms of DDL, what you have to change, it's quite straightforward. So it means replacing some things like you don't care about anymore about distribute on, organize on, and those specifics of Netezza. So you can completely remove this. This is done automatically by Snowflake. It's the same naming convention in terms of three-part name. So you have a database, schemas, and objects. So whatever you have written, it will work the same on Snowflake. What is important that if you are using some synonyms, Netezza, let's say Snowflake does not support this, so you have to use the full name. So this is usually mostly used on Oracle clients, but this is something to watch out. And also one specific of dropping objects. So on Snowflake, only owners can drop it. So this is something also that you have to take when you set security and think about it, how you will do it, which role, user, and etc., as Jakob also explained. So this is also important. Maybe some conversions just to understand what needs to be changed. So there are some functions, of course, that are different. So let's say age today diff, now it's called current timestamp on Snowflake and etc. So if you need a list of those functions, we have also this in our parser already built in so that it can translate these standard changes. What is maybe more important if you are using some more advanced date interval functions or date functions in Postgre, because it's quite rich with these capabilities, it means that there will be a little bit more work to be done because on Snowflake you have these specific functions that enables you a similar functionality. Also, a lot of our clients, or even all of them, use the Netezza toolkit. So this is an additional database, if you remember, that you can install on top of Netezza, and it's some extension of functions, let's call it like this. And of course, some of those things have to be migrated. Some of them are, let's say, natively supported, like usually our clients use some functions like greatest that selects the biggest element. So this is also, let's say, native on Snowflake. Of course, if some functions are not supported, you have to rewrite them. So Snowflake supports user-defined functions. You can use the SQL syntax or JavaScript syntax. So for such things, it's, of course, some additional work to be done. If you are maybe using Netezza user-defined functions, which you had to write in C++ and compile them, then, of course, alternative is UDF functions. So also in the future, in the preview, I think a closed preview at the moment, Snowflake will support Java functions. So even if you're doing something more complex, that maybe you struggle with writing this in JavaScript or in SQL and would like to have this support, this is coming. So if you're doing now migration and this is critical, you can also contact Snowflake to enable this on your account. Stored procedures, the hardest part, like always. So there is different syntax. So if everything else previously was, let's say, easy to do, or let's say clear how to do it, when it comes to procedures, it's quite different. So if you look at some of the logic, we try to add here some examples. So on Netezza, you just define the types as a parameters, and then define what the name of each parameter and mapping, and then you use these parameters. Let's say, for example, when it comes to, and this is a simple, let's say, procedure, of course, very simple one. But just to understand, so Snowflake currently supports JavaScript notation. SQL notation is coming this year, but currently it means all the attributes have to be here available as a parameters in the header. And then we have to have this specific notation, execute SQL of Snowflake, and then having this let's say enclosed characters, the statement that we want to execute. So these are some specifics how the stored procedures are different, and I will talk a little bit more now with further examples. So some things to watch out that we learned the hard way is if you remember in Netezza, you have the ability to reference the table back. So it's some sort of like in SQL or in Oracle where you have the ability that you return a record set. So here is on Netezza, you have to create the table, and then in the procedure, you reference back the table. So this tab one has to be created, but the procedure can return the result back. So, okay, if you're using this in the data integration process in ETL, that you have written some of your custom code, then it's, let's say, easy manage. It means you have to rewrite it a little bit different, have some intermediate tables and etc. on Snowflake to solve this. The problem is if you use this as a BI input, so that on your BI side, you execute this procedure, you get the result back, and you present this. So if you're using Snowflake, then there is a problem with this approach. So watch out, if you have such thing, you will have to probably remodel your BI environment also. So this is something to really watch out. And this is something that we encountered on one project. And then at the end, we had to also remodel the BI. So they said that the BI is not, let's say, up to date, and it's not okay how it is set up. So it was like a second project for them, but it had to become part of the initial migration project so that everything would work. Dynamic execution of SQL, as I have already showed there. So you have the execute statement, you specify the SQL text, you can include variables. So different notation, but a similar result. Regarding to JavaScript, what is important on Snowflake at the moment, all the parameters are treated as strings when it comes to specific. So it means that it will change because I think it's already supported the new JavaScript standard, and it will support other data types, but currently it means the input is a string, and it means you have to do some modification. So it means, let's say, a simple thing that you would like to get like a date out of it, it means you have to write your own function inside the procedure, of course, JavaScript notation. So to get this back, let's say, for example, getting the timestamp back from that, what you got the parameter. So you have to play around a little bit. Also, if you are doing some cursoring or repeating over or have some while statement, something like that. So in Snowflake, you have to prepare the statement, you create the statement, you execute the statement, and then you loop over. So you have the next command that loops over the code. And of course, these things are hard to, let's say, automatically change. So it means this is usually the majority of work depending on the number of the procedures. Maybe just one additional example, how to get the number of rows, let's say, that were inserted. So you have, let's say, additional logging mechanism that you would like to implement in your some specific logging tables. So what is possible in Snowflake that you can query what was executed last for specific session. So, and it will be done from the cache. It means it's like not using any warehouse. And how do you do this? You have the function called result scan, and you can get the last query ID function. So, and then you get what was inserted from this result. And then, of course, you can just execute, get these counts from the result, and then write this into, use this in, let's say, next dynamic SQL statement that you would like to do. So there are some things that, let's say, change when you are using, of course, JavaScript then in this case when it comes to Snowflake. Okay, next part, optimization. So someone will say, okay, Netezza is very fast. We did not have to optimize anything. You know that you had to optimize something. And also on Snowflake, we are dealing with the similar, let's say, logic, no optimization, no maintenance. So, but there are some caveats that we would like to emphasize. So usually no one wants to compare. So what do you need if you have a full rack Netezza? So from our experience running, I would say, quite large clients, intensive workloads, a lot of users. So I would say that without any optimization based on our tests, it's very similar to Snowflake XL. So if you would just like to go with the raw power. So it's very hard to compare because one is column store, one is not, and they both work differently. But still, just for the sake of comparison, you move everything one-to-one, you don't care. Usually the XL will be something where Snowflake will start to become better than full rack Netezza. What is, let's say, the optimization approach in these cases is that you always check the most demanding queries. You check all the most demanding queries, and you see on Snowflake if it scale. What does it mean on Snowflake if it scale? It means that if you select a warehouse, let's say size M, you run the query, you select the warehouse L, you run the query, do you get, let's say, 1.5 or even, let's say, twice the performance? And if you get the same performance, it means that your query doesn't scale. There is some issue either with the distribution inside the query engine of Snowflake or something that or your query, how it is written, of course, that it doesn't make it good. So what are some optimization possibilities that you can use? So if you're using really large tables and you have large scans and you're doing always some selective where clause, then it makes sense to use clustering. Even if the selective, let's say, predicate has a small number of different values. We had cases when it has, I don't know, 30 different values or 20 different values, when someone will say, oh, this is stupid. But it makes sense because the data will be ordered and it will scan just the part that it needs. And it means on, I don't know, 5 billion table that scans 1 minute, it can become 5 seconds, which makes a lot of benefit at the end. And then what we also do a lot on very large and complex things is this intermediate materialization. So it means you take the parts of the query that work slower, that don't scale, and then you create a table out of this and use this table as in the next step. And then you get this scaling effect back, and this is how you can fix this. So, and another approach, maybe the last approach is on Netezza, it's like brute force. And if you have, let's say, multiple steps inserting simple queries, inserting 30, 40, 50 millions of rows, it's maybe better to write everything in one big sentence on Snowflake. It will perform much better. So these are, let's say, possibilities how you can check. But this is usually only for really those demanding queries. So the question is always, why optimize? So if it works the same, better, it costs less, why would you optimize? So that's the question. But when you come to the cloud, remember that each optimization is directly linked to your cost, directly. So I will show you then in the next slide some examples. So it means that if you can run something on M, on Snowflake, and not on L, it means you will save twice the credit. So it's really important to understand this part. That's why on large queries, it makes sense to see if there is some optimization. So on Snowflake, you have very good visual execution plan. You can see exactly what's going on. You have the full query audit table. You can see all the demanding queries. You can analyze everything, have a good dashboard, let's say, of on top of your Snowflake to see what's going on as a DBA. Maybe also what we saw, it was usually the question, which warehouse should we use if we have Netezza? That's completely wrong discussion, because Snowflake enables you to parallel and completely isolate the process, which means that you can use multiple warehouses, some small, some bigger. You will give to someone a smaller one, someone a bigger one, depending on what he's doing. And with this approach that you can immediately scale and rescale, it's a completely different picture. But if you really want to go, let's say, one by one, it's something that I explained briefly in that area, what you can compare. But still, it's completely different logic when you want to really analyze how you want to run your Snowflake environment. Okay, some examples. We had, this was our latest POC. Procedure, very demanding procedure. It loads, it has 25 steps. So each step, complex SQL, storing somewhere the data, and then doing this over and over again. So some very intensive. Why? Because we have a two-level data warehouse. So we have an atomic model, super subtype model in this case, and then we have dimensional model. So as you are familiar, if you have, I don't know, data vault and go to dimensional or anchor type, it means that this query between, it's usually quite complex, a lot of left joins and doing all the magic that needs to be stored from the let's say more normalized model to the dimensional model. So the goal was main table 1 billion rows, clean insert into, and see the performance. So if we can see different procedures, so the biggest one was this procedure 1, then we have similar procedures, but just to see. So with no optimization, nothing. So we take it as it is, replace what needs to be replaced. We saw that this line is Netezza, full rec. So we see that it took on Netezza, I think around 10 minutes, something like that. And then on M, we were at 8 minutes on Snowflake. With L, we were at 12. With XL, we were below. So as I said, between L and XL, there is somewhere the full rec, if you would be really like on large queries, of course. So we see that this is some example. But then we optimized. So we looked at the parts that don't scale, and we start optimizing. So what we got, as you see on L, we came to the same result. So we got some 20%. But then when we optimized also extra large, we got even better. So we got even lower on some cases. So this is important then to see how it behaves. And of course, it means you save at the end money. So it's important. Also, in some cases, let's say this one is quite important. Let's say this procedure number 3. You see here, the performance was the same on L and XL. It shows that all the process, all the steps don't scale. So there is some wrong in our code, something wrong in our code. So the idea was when we optimize this, you see what happened. We went with extra large to less than 2 minutes. So it means we saved 80% of time. So it's very important, really, this part. Again, on large queries, don't optimize 5-second queries, because we all know so where the majority. So this is something that it makes a lot of, I would say, impact at the end, and also cost savings when it comes to moving to the cloud. So what do you, at the end, what do you do not need to worry about anymore? So data distribution, we said, no worries. Groom, vacuum, no longer available. This is something that Snowflake does for you. Statistics, so generate statistics, very, very important on Netezza, very important. So when you reload, you have to generate statistics on Snowflake automatic, so you don't care. Workload management, if you remember on Netezza, from our experience, it works so-so. It was never properly implemented, so usually people run with admin all the main jobs. But on Snowflake, as we said, we have this total isolation. So you think about warehouses, you think about your loads as warehouses. So this is important. Capacity planning, you don't care. You can scale to 10 terabytes immediately, 100 terabytes, don't care. Disaster recovery, you don't care, because you can even distribute outside the specific cloud. So you have a lot of capabilities. And what is mostly important, what we see, is this ability to have immediately the development environment, so that you can create your dev and test environment on the fly with cloning functionality, no backup, no restore, no additional boxing, etc. So these are huge benefits at the end, and maybe probably also the reason why you're moving to the cloud. So if the question will be, what about if we are using DataStage Informatica, which is usually used quite a lot in these cases? So this is very complex question. Then it's an additional complexity when it comes to migration. Maybe we cannot do lift and shift in this case. It has to be redesigned. So if you're interested in this, please drop us a note and we'll prepare one WebEx also on this subject. So we cannot cover this now in this hour. So maybe at the end, just to present a little bit some of the things that we developed, as our focus is especially on migrations. So what Jaco explained, parallel extraction, parallel import, creating DDLs automatically, testing the bandwidth, everything automatically. So we have our own asset called Ant Farm, and you can immediately transfer thousands of tables from any kind of system to Snowflake. So we use this also in POCs when clients demand a more demanding POC. The other part that we developed is our automated code conversion. So all the things I explained, from the simple ones also to the complex one. So we can generate, I would say, almost 90% of the stored procedures that are in Netezza to Snowflake dialect. So this is very important. So we built a really specific parser that builds an object model that we can then know the context, because as you saw, things switch when you use different languages, and we have to support this. So these are some things that can help you, and if you are interested, drop a line to Clement and we can discuss further so that you minimize the risk when it comes to, of course, migration. So thank you all for attending, and maybe if you got some questions while presenting, maybe Clement.
Yeah, let me check if we have any Q&A. We have a couple of questions. Just let me read one out. How much can the night batch duration be optimized in your opinion?
As you have seen, if we can scale it, like in this case, it means that you can just run for specific query, you run the extra large. It means you can really just linearly, just selecting different warehouses and optimizing, you can really shorten this period. But what is also important on Snowflake, that if you're inserting in the same table, you can do from the multiple processes. So you can maybe run 10 things in parallel, because each one you run on different warehouse. Even though the Snowflake warehouse has, let's say, 4 queues in parallel, but it can still be maybe a bottleneck. So you really rather distribute on multiple warehouses. And this can really significantly drop your nightly batch. So there are a lot of nice tricks that you can do, especially if you are running tight on the night batch window. So,
yeah, for those of you that are not aware of how the workload oscillation works on Snowflake, you can check our news or the previous webinars where we were basically discussing how Snowflake actually works in practice, and you're going to see how this workload isolation actually works. Another question would be, okay, this is not directly connected to the Snowflake or Netezza, but we're using Cognos on top of Netezza. Are there any specifics we have to watch for or be prepared for when doing the migration?
Cool. Okay, this is maybe a question more to my BI colleagues. As I know, there is a native IBM and Snowflake driver for Cognos. And if I remember, yeah, we had one issue. I think that if you're using in Cognos subqueries, so that I think if you in the filter you use subqueries, it's been a while since I used Cognos. I used to train Cognos. But if you're using subqueries, so that in the filter you use a query, I think it's not supported, and we had some issues the last time we did some. It was, I think, on one POC, but I would have to check with my colleagues, so I can get back to you then.
Okay, we touched this one a little bit. We have to export data from Netezza to the other systems. So how do we handle that?
As we said, from Netezza, you have to export from the Netezza existing to another system. Exactly. Okay, so you're using probably NZ unload and all those things, or external tables, as Jakob mentioned. So on Snowflake, you have the same capability. You can export it with a command line interface or some Python directly to your environment, or you can export it first. Snowflake supports this because of this, let's say, hybrid data lake architectures to S3, GCP, or blob storage. So this is also then another approach, and then you put it forward wherever it needs to go. So it will export this as a CSV and zip it. So.
Okay, and the last one from the audience, how do you compare the administration between the two? I think we touched this one a little bit, but maybe you can.
Yeah, I would say that all of you that are used to using Netezza, you cherish the simplicity, no administration. So you are not in that camp of Exadata where you have a strong DBA and it works then also perfectly. So here on Snowflake, they went, I would say, one step further. So as I've seen, so you don't need the distribute, don't need so much organize. You have some similarities by this cluster, but at the end, I would say even lower administration, no vacuum, so even less.
Okay, and maybe one for the finish from my side. So how do we handle the assessment? So how can we help our prospects or customers going from Netezza to Snowflake or basically any other cloud with our services approach?
Yeah, we have this standard approach when it comes to migration, but let's say if you just would like to see what would be, let's say, the code conversion part or just some part of the migration process, we can, of course, do here some, let's say, quick checks to see what our, let's say, internally built tools can help you, how can you be quicker, or just if you need some discussion about some specific topics. So we are here quite open when it comes to migrating the data. And as we said in the first webinar, each migration is complex at the end, even if it looks maybe on paper easy. So there are no easy migrations, I would say.
Okay, I think that's all for now. If you have any other questions, please drop me an email. We'll be happy to answer. Or if you'd like to do a POC, free to test Snowflake free trial, or give us a call and we'll be happy to help out. For now, I think we're done, and I'd like to thank you all for joining. Please stay tuned for the next webinars. You're gonna get the email from our marketing team and let us know your thoughts. Thank you and have a nice day.